Alright, you are welcome back. So we stop at this differential equation, that is conductivity multiplied by the partial square c over partial y square plus mu into du dy square equal to 0. So we can divide both sides by k. So that will give us this equation. And then remember, this equation is partial differential, but because it is one dimensional, we can change it to total differential because it's only depending on one single variable. So that gives us the square c over dy square is equal to minus mu over k into du dy square. But remember, when we were solving for the velocity profile function, we got our u1, the u dy to be c1, which is same thing as v all over l. So if you plug in this value into this equation here, you have the square c over dy square is equal to minus mu over k into v over l all square. So now we'll go ahead and integrate this function so that we can get t as a function of y. So the first integration, we have the square t over dy square is equal to minus integral of mu over k into vl all square dy. So integrating this part will give you the t dy. Then integrating this one, all these are constant with coefficient of 1. They are having coefficient of 1. So when you integrate 1, you will get y. So that's why you see y here. Then since it is an indefinite integral, we are going to have constant. Since we have already used c1 and c2, so we have c3 as the next constant. So again, we'll go and integrate again. So if you integrate the t dy here, you have t of y to be equal to minus mu over k into v all over l square. So if you integrate y now, you have y square all over 2 plus this one will give you c3y, then plus another constant c4. So now we need to apply boundary condition. So the boundary condition is at this surface of the plate, the temperature is equal to T0, and at the upper plate too, the temperature is at L, the temperature is also T0. So we substitute the value now. So we have
Oga, this your pi L, you need to explain.
Pi L is just a function that is representing temperature function.
This is language that
Pi L is a temperature function. Okay, let me put T here so that
don't worry.
T of
in case
L,
of next time, just explain. Let's use it.
TL.
Okay.
So
let's leave it as fine, no problem. I just want to.
Now, wherever you see y in this function, you substitute 0. So you have t of 0 is equal to t0. So this will give us minus mu all over k into bracket v over l square. This one will give us 0 all over 2 square. 0 square over 2 plus c3 into 0 plus c4. So this part now equal to 0, this one equal to 0. So we have c4 equal to t0. So we substitute this t0 back into this equation. So we have t of y is equal to minus mu all over 2k into bracket v all over l y everything square plus c3y plus t0. So the other one too is we substitute L. So we have T of L is also equal to T0. So which is equal to minus mu all over 2k into V all over L times, wherever you see y substitute L, you have L all square plus C3 L plus T0. Of course, T0, let me write. So you have T0 is equal to L will cancel L. So you have minus mu all over 2k into V square plus C3 L plus T naught. So this one remove this one. If this one comes to this side, it becomes C3 L is equal to mu all over 2k V square. So C3 now will be mu over 2k V square all over L. So we will now substitute this value again into this equation here. So we have T of y is equal to minus mu all over 2k into brackets V all over L y all square plus what our C3 mu all over 2k V square all over L then plus T naught. So we can factorize this one as T of y is equal to mu all over 2k into brackets. Here we have V square y square all over L square plus this minus minus y difference plus plus V square all over L then plus T naught. So we have T of y equal to mu all over 2k into brackets. This square is common to the 2. We have this square all over L into ẹ̀yin náà lẹ́yìn bá ṣe jọ́nà bí i ẹ̀rọ ìlẹ́yìn ká ṣe. So when I was explaining, we forgot to put y when we were substituting from our C3 here. So when we plug in back into this equation, we have minus mu over 2k into V over Ly all square plus C3. T3 is mu over 2k V square over L, which is this, then times y, then plus T naught. So if you factorize, you come up with this. So this is the equation for the temperature profile. While for the velocity, which we have derived earlier, is u of y is equal to v all over L y.